Hey guys, my name is Trevor Sullivan. I am a solutions architect with StratusGrid. StratusGrid is a business that is an AWS consulting partner, and we deliver a lot of software engineering and cloud engineering based projects where we migrate to the cloud, we build net new workloads in the cloud, we do cost optimization and things of that nature. So if you're interested in engaging with our cloud engineering team, then feel free to go to our website at stratusgrid.com, hit this little Let's Talk button, and then go ahead and fill out the form to have a consultation with our sales team. So the topic that we're going to be going through in this particular video is a relatively new service in the AWS ecosystem, and this is part of the identity service, the Identity and Access Management Platform, or IAM for short. And so what we're going to be doing is focusing on a specific service within the IAM component called the IAM Roles Anywhere feature. So essentially what this allows us to do is, rather than having static credentials where we go create an IAM user and we have an access key ID and a secret access key, those are our static credentials that are long-lived. They exist until we actually go in and explicitly delete them and rotate them in an infrastructure virtual machine or an application that's accessing AWS services. Rather than having these long-lived credentials through IAM users, we can actually set up IAM roles or application identities that have short-term, automatically rotating credentials so that we're not embedding these long-lived credentials in our application. This is a great security practice because having long-lived credentials means that attackers that intend to use those credentials for malicious purposes, they could compromise the security of your data, and they could also spin up resources in your AWS account that end up costing you tens or hundreds of thousands of dollars, or maybe even millions of dollars, that you don't actually get any value from, right? So we want to avoid these types of attacks that involve attacks directly trying to obtain long-term credentials. So if you have any applications or infrastructure virtual machines that are running outside of AWS, they're not running in EC2, they're not running in AWS Fargate, they're not running in AWS Lambda. If you have, let's say, VMware infrastructure on premises in a self-hosted data center, then you want to be able to access AWS services. Maybe you need to talk to DynamoDB, maybe you need to talk to Amazon S3 storage, right? And the way that we can actually get credentials, short-term credentials from these on-premises infrastructure VMs or applications is to use this feature known as IAM Roles Anywhere. So essentially the way that this works at a high level is we provision what's known as an X509 client certificate to our application or virtual machine, and then we can use that X509 certificate to validate against a root CA that we import into our AWS account. And then once that certificate's been validated, we can actually get returned some temporary credentials using an IAM role for the permission set or the policy permissions that we need to have to certain services. So for example, let's say that you have an application that simply needs to store data in Amazon DynamoDB NoSQL storage. Well, what we can do is we can create a role that only has permissions to the DynamoDB service, and even more specifically to a specific DynamoDB table that it needs access to. And then we can authenticate to AWS by using IAM Roles Anywhere, and then any credentials that are provisioned through the IAM Roles Anywhere service to that application are only going to have permission to that DynamoDB table, and those credentials are short-lived, meaning that once they expire, they are no longer good, right? So the application will have to periodically retrieve new credentials through this process that we're going to be discussing in this video here. Now, this is really cool. It's actually really similar to binding an IAM role directly to an EC2 instance in AWS, or binding an execution role to a Lambda function, or if you're using Amazon Elastic Container Service with Fargate or the infrastructure deployment type, then you can actually bind what's known as a task role to the individual containers or tasks that you're running inside of the ECS service. And so thanks to the kind of backend trust that EC2 or ECS or Lambda Lambda have with the AWS IAM service, they're able to just directly inherit those roles without having to jump through this authentication process. However, the key benefit here is that we can emulate that type of trust relationship between our on-premises compute services and the AWS IAM service so that we can still get the benefits of using roles instead of IAM users with long-lived credentials. So what we're going to be doing is actually going through the setup process here. I've actually got an AWS development account right here in front of me. And if we go down to the IAM Roles console right here, so you want to navigate over to the IAM service in your AWS account, and then on the left-hand nav, we're going to go down to Roles here. And if you scroll all the way down, you see this new section down here called Roles Anywhere. And if we click on Manage here, it's going to show us the different resources that we can create in order to set up the Roles Anywhere service. So the first thing that we need to do is have a root CA, also known as a certificate authority. And then once we import that root CA certificate as what's called a trust anchor right down here, you can actually see that I've already imported 2 different root CAs that I've created for testing purposes. We can go in here and just create a new certificate authority as a trust anchor, and then that trust anchor will be used to validate the actual client certificates that we provision out to our infrastructure VMs or applications running on premises. And then we have this other resource down here called a profile. And a profile is pretty simple. All we do is give the profile a name, and then we can specify which IAM roles we are authorizing for providing credentials through this particular profile. And once we create the profile, we will have to specify its Amazon resource name or ARN in order to specify which profile it is that we're trying to validate against and assume that role that's associated with it. You can also add additional roles beyond just a single here. So a profile can actually specify multiple roles. And then when you request credentials, you simply tell it which role it is that you're trying to assume. And if it's not in the list of authorized roles, you'll get rejected. But if it is in the list of authorized roles for that particular profile, then it will allow you to retrieve credentials. So I have a blog post that actually steps through this process as well. So feel free to head out to the stratusgrid.com website, go to resources and then blog right here. And there will be a corresponding post that covers the process that we're going to be stepping through here in written form. Now, you might be wondering, well, how do we generate a root CA certificate, and how do we generate these client certificates that are signed by that root CA certificate? Well, that's a great question, and you might think OpenSSL, but we're actually going to be using this other open source tool called the Step CLI. So there's this company out there called SmallStep, and they've actually developed this tool called Step CLI. It's a cross-platform tool that you can use to work with certificates. You can generate new root CA certificates, you can generate client certificates, you can create intermediate CA certificates, and it actually does a lot more than that. It also works with other types of authentications like OAuth, for example, but we're just going to be focusing on the X509 certificate functionality since that's what we use with IAM Roles Anywhere. So this is the GitHub project page. It's github.com/smallstep/CLI. And if we head over to the releases section right here, we can just hit releases here. And then you'll see that there's precompiled Linux binaries, precompiled Mac OS or Darwin binaries, as well as a Windows binary here. Now, my local system here is a Windows 64-bit system, Windows 11. So we're going to go ahead and download this zip file here. And then I'm going to go ahead and extract that in another window here. So I'm going to go to my downloads folder here, and we're just going to open up this Step CLI zip file. Then we'll navigate into the subdirectory there. And as you can see, we just have this step.exe file here. So we can just move that into a temporary directory. So I'm going to create a directory here called 2024-Q1. And I'm going to go ahead and paste that in there. So now I can go into this directory on my file system and kick off the step.exe binary. Now, keep in mind that if you're on Linux or Mac OS, when you download the step binary, you may have to do a chmod operation in order to make it executable. So you just do chmod plus X to make it executable. It may already have that bit set, but I'm not entirely sure from when I previously did it on Mac OS. All right, so now we've got that binary. We don't need the zip file anymore. So now we have step CLI available. So in order to use step CLI, I'm going to fire up a terminal window here. And I am using PowerShell on the Windows platform, but you can actually install PowerShell Core Edition on Mac OS as well as Linux natively as well. I generally use PowerShell because it's an object-oriented shell, but you can also use Bash if you'd like to. So I'm going to cd into this directory, and if we look at the files in there, of course, we just have the step CLI right here. So what we're going to do is do /step, and that should kick off the utility here. As you can see, we get some help printed out, and the command that we're going to be working with here is called the certificate context. And then under the certificate context, if we do /step and then certificate, we'll actually see a bunch of additional subcommands right here. Let me try running that again. And these allow us to do things like create a certificate. We can inspect a certificate and a whole bunch of other stuff here. We even have verification. We can sign certificates if they're not already signed and things like that. But we're going to be focusing on this create command. So if we do step certificate create -- help, you'll see a list of kind of examples that you can use in the step CLI. So if we want to create a root certificate, we can go right up here, create a root certificate and key. And so what we're going to do is say step certificate create. Then we're going to specify a subject name for the certificate. You can call that whatever you want to. Then we have the public key file for the CA. And then we have the private key file for the CA, which needs to be protected by a password so that not just anybody can use that CA. It's a very sensitive private key, and you want to keep that very limited access to certain individuals. We also have this parameter here called -- profile. So step CLI supports these different profiles for things like root CA certificates or leaf client certificates and things of that nature. So we would specify that we want to generate a root CA certificate here using that profile parameter. So all we need to do is emulate that command in our terminal here. So we'll say step certificate create. We'll specify the subject name of StratusGrid 01. And you can put spaces in the subject name as long as you have quotes around it. Then we'll specify the public key path. So we'll call this StratusGrid 01-ca.crt. And then we'll also do StratusGrid 01-ca.key. And so the file extension, either CRT is going to be the public key, or the .key extension will be the private key. And then we also need to specify -- profile and say root-ca as the value. So that'll go ahead and prompt us for a password here to encrypt the CA private key. I'm just going to use a weak password here since this is a test cert of ASDF. And so now in our directory here, we have the step binary that we just called, and we have these two files, the public key and the private key. So what we want to do is grab the contents of the public key, and we're going to import that as a trust anchor into our AWS account. This is kind of the first step where we go into our AWS account and say, I want this certificate authority public key to be used to validate the signature of any client certificates that we generate later on for applications and infrastructure. So we're going to say cat the StratusGrid CRT file, not the key file. We want the public key instead. So we're just going to copy this to our clipboard right here. Then we're going to come over to our AWS Management Console right here, and we're going to go to Roles, and then Roles Anywhere. Again, you have to scroll down to the bottom of Roles here. Go to the Manage button right here. And then we're going to go ahead and say, I want to create a trust anchor. So once it goes into the Roles Anywhere screen, we'll go ahead and create the anchor. Let's hit the Create a Trust Anchor button right here, and then we'll give it a name. So I'm just going to call this StratusGrid 01-ca. And then you have a couple of different options for the certificate authority source. You can either create a private certificate authority inside of your AWS account. There is a cost for that. I think the last time I checked, it was like $400 for a private certificate authority. So in this case, we're actually not going to be using that managed service. We're going to say, I have an external certificate bundle, and then all we have to do is paste in our root CA public key into this box right here, and then we just scroll down and say create a trust anchor. So now we have imported that trust anchor, and what we need to do is copy the ARN down here of that trust anchor to our clipboard, because we're going to need that when we create the IAM role, so that we limit the ability for that role to only be used by this specific trust anchor. We don't want it to be usable by any trust anchor. We only want this specific certificate authority to be allowed to assume a particular role. So what we're going to do now is actually create the role itself, and this is what's going to specify which permissions this particular identity has. So we'll say create role. Then we're going to specify a custom trust policy here. This is basically saying who is able to consume this role, or assume this role, I should say, and retrieve credentials with it. If you head over to our blog post or the AWS documentation here, they actually specify exactly what you need to do for a trust relationship. So if we go to creating a trust anchor and profile and scroll down a little bit, you'll see this little snippet right here, or again, you can grab it from our blog post, and you can go back in here and simply paste in that statement, or actually the entire policy document here. So let's go ahead and paste that in. And what you're going to see is that the role assumption is going to be limited to only the Roles Anywhere service. No other services in AWS are trusted, like Lambda or EC2 or ECS or anything like that. And then there's 3 specific actions that we need to authorize in order to retrieve credentials. Those are already in there. And then finally down here under the condition, this is where we have a conditional statement that says only this specific trust anchor is going to have permission. So what we do is we paste in the ARN of our trust anchor into that. So we'll paste that in. This is my unique ID of my trust anchor, but of course yours will be different depending on your account ID and the specific UUID that is generated by the platform for your trust anchor. So once we've got that assume role policy document set, we'll hit next, and then we can attach certain permissions. So for now, for the sake of example, I'm just going to say you have full access to the Amazon S3 service, as long as you're using this role. So then we'll hit next down here, and we'll give it a name like Stratus Grid 01 IAM Anywhere test. And then we'll go ahead and hit create role. All right, so now this role has permission to S3, but it's only usable by the trust anchor that we've specified. So now what we need to do, now that we've configured our trust anchor and our role, is we need to go ahead and specify a profile. So the profile is actually going to reference the role that we just created here and authorize that role for use when we attempt to authenticate using a client certificate. So now that the role's created, we'll go back to the Roles Anywhere service here and hit the Manage button, and then we'll go ahead and create the new profile. Here's the trust anchor that we just created earlier, and now we're going to go down to Profiles here, and we'll say Create a Profile, and then I'll give the profile a name, like Stratus Grid 01-CA, and then right here, you can actually see a drop-down list of any supported IAM roles here. And keep in mind that if you don't see your role showing up in this list, then it means that you have an invalid trust relationship configuration. It probably doesn't trust the Roles Anywhere service. So you need to make sure that that trust relationship is set properly according to the documentation in order for your role to show up here. So we'll go ahead and choose this new role that we have created. Also, you'll notice that when a role is already referenced by another profile, you can't have more than one profile referencing a role. However, you can have a profile that references more than one role. So roles can only be used by one profile at any given time. So we're just going to choose that one role. I'm not going to add any others right now. And then there's this feature called session policies. And what this allows you to do is to limit the permissions that that role has. So we gave it S3 full access permissions policies in the IAM service. But when we actually request dynamic credentials through the Roles Anywhere service, we have the ability to limit further the specific permissions. So if we wanted put object, create bucket, delete bucket permissions, and no other S3 permissions, then we could specify only the permissions that we want to allow in this session policy right here. So it kind of works similarly to how service control policies work at the organization level, where they don't grant permissions, they simply limit any permissions that you already have. So I'm not going to specify anything for that. And then we'll specify to create the profile. Great. So now we've got the trust anchor, the certificate authority's public key. We've got the role created, and we have the profile that references the role. Also, I would note that the profile is a resource, so it does have an Amazon resource name, and we're going to need the ARN of the root CA or trust anchor. We're going to need the role ARN, and we're also going to need the ARN of the profile a little bit later on. So just remember that we need those 3 bits of information from the AWS Management Console. All right, so now that we've got those things set up, the next thing that we need to do is to actually generate a client or leaf certificate that is signed by the certificate authority. So what we're going to do is head back over to our terminal right here, and we're going to use the step CLI once again. So we'll do /step certificate create. And then this time, we're going to be looking for an example that allows us to, let's do --help. We're going to be looking for an example that allows us to create a signed leaf certificate. So what we're going to be doing here is finding the create a leaf certificate and encrypt the private key. But the only thing is we're not actually going to encrypt the private key. We don't want to have a password on the client certificate, because when we actually use that private key for the client certificate, it can't have a password because of a limitation in the binary that we use to actually assume the role. So hold that thought, but we're going to go ahead and say step certificate create. Then we're going to specify a new subject name for the client cert. We're going to specify a new path to the new public key that gets generated. Same thing for the new private key that gets generated. And then we're going to specify the profile of leaf instead of the root CA. And then we also need to specify the CA's public key. So what is the certificate authority's public key, and what is the certificate authority's private key? And those will be used in order to sign the client certificate so that it is properly chained up to the root CA cert. So what we're going to do is say step, actually /step certificate create. We're going to specify a new subject name. So I'll say client 01, and let's prefix it with stratusgrid 01. And then we're going to do stratusgrid 01 -client.crt. That'll be the public key for the client. And then stratusgrid 01-client.key. That'll be the private key for the client. Then we want to specify the profile --profile is going to be a leaf or client certificate. Then we're going to specify the CA certificate --CA. We'll specify the stratusgrid 01-ca.crt file. So that's the public key. And then we'll say --ca-key. This is going to be the private key for the CA. So I'll go ahead and specify the key file for the CA here as well. So if we hit enter here, it's going to generate a signed client certificate by the root CA. It's going to prompt us to decrypt the CA's private key, because we need access to that private key from the root CA in order to sign the new client certificate. So I'll do ASDF there. And then when it prompts us to encrypt the private key for the client certificate, we don't want to do that. We do not want a password on the private key for the client here. So as you can see, it's going to force us to specify one. However, we can actually remove that password later on. The way that we can do that is with the step CLI once again. There is a command in the step CLI called crypto. And if we go into the crypto context right here and take a look at the help, there is a change pass command right here. So that allows us to change the password on an existing private key. So what we'll do is say step crypto change pass, and then specify the client.key file here, right? So what we want to do is specify the current password. I just used ASDF, and then we're going to specify no password. Just hit enter, and then we'll say, yes, we want to overwrite that file. So now the client certificate does not have a password. It's not encrypted with a password any longer, and we can now use it. So let's review really quick and look at the files in our project here. We've got the certificate authorities, public and private key. We've got the client or leaf public and private key, and we're good to go now. We can now go ahead and try to retrieve credentials from IAM Roles Anywhere using this client certificate right here. So how do we do that? Well, there's actually a CLI tool that's developed by AWS specifically for this purpose. If we head over to the IAM Roles Anywhere documentation right here and take a look at obtaining temporary security credentials, if we scroll down just a little bit, you'll see a reference to this application right here. It's called the AWS Signing Helper. So I'm going to go ahead and download the executable here for the Windows platform. It is also supported on Linux and Mac OS Darwin. So we'll go ahead and just download that executable. And then I'm going to go ahead and go into my downloads folder and just move that executable into our working directory here. So I'm going to go into our 2024 Q1 folder and we'll paste that executable in there. So now we have all of the files that we need inside of that directory. So now the final thing that we need to do is to actually construct the command using the AWS Signing Helper in order to specify the root CA trust anchor, the profile ARN, the role ARN, and then the reference to our public key certificate for the client and our private key for the client as well. And then this utility here, this AWS Signing Helper, will actually return back to us a JSON blob containing the access key ID, the secret access key, and thirdly, the session token. And those three components we can use to then authenticate to the AWS platform, to the S3 service in particular, and we should be able to use those credentials successfully. Now, I'm not going to actually use those credentials. I'm just going to show you how to generate those credentials and get that JSON blob back, but this is all done using the Signing Helper utility. So what we're going to do is call Signing Helper and then credential-process. So we'll do /AWS Signing Helper.exe. You don't have to specify the .exe there. PowerShell automatically knows that it's an executable. Then we'll say credential-process. And now we have to specify all those different parameters, right? So we're going to start with the public key since we already have that locally. So we'll say --certificate. We'll specify the client.crt file. Then we're going to do --private-key. And we'll specify the clients.key file, which is not password encrypted. Then we need to specify the role ARN, right? We need to specify --role ARN, profile ARN, and trust anchor ARN. So we're going to get all those values from the AWS Management Console here. We'll go back to I'm going to go ahead and copy the profile while I'm already in the Roles Anywhere console. I'll go ahead and copy the CA as well. And then we'll go ahead and go to the roles and I'll search for 01. Here's my role that we just created a moment ago, and I'll copy the ARN for that. So then I'll go ahead and paste in the role ARN. Then we'll specify the profile-ARN. We'll paste in the profile ARN right here. I'm just going to double check that parameter name really quick. Yeah, it's profile-ARN. And then we're going to do trust anchor ARN. So we'll say --trust anchor -ARN. And finally, we'll specify the trust anchor ARN on our clipboard here. So those are all the parameters that you need: the client, public, and private key pair, role ARN, profile ARN, trust anchor ARN. And remember that the profile references the role, so we know which role we're going to be authorized to utilize through this service. So when we hit enter here, you can see that we get generated a bunch of credentials, right? So we have our access key ID, the value right here. We have the secret access key, and then we also have the session token. And we also have the expiration date and time right down here. So our application, when this is about to expire, maybe 15 seconds before it expires, we can simply call this same command again and retrieve a fresh set of credentials. And that keeps our credentials rotating over and over and prevents us from having long-term credentials. The only thing that you really want to pay attention to here is that the key for the client certificate right here is a very sensitive piece of information, because if somebody gets the private and public key pair for our client certificate, they can now impersonate us as long as they know the role that's authorized, the profile that's authorized, as well as the trust anchor that the certificate needs to be validated against. So with all 5 pieces of those information, someone could actually impersonate you, but it's pretty hard to do because X509 certificates are pretty darn secure. So that's how we can retrieve these dynamic rotating credentials, by using roles outside of AWS compute services. Maybe you've got a virtual machine or maybe a container image running some application on DigitalOcean or Linode or Vultr or some other cloud provider out there, but you need that application to talk to S3, DynamoDB, or any other AWS service. This is how we can retrieve secure credentials every single time that we need access to them. So that concludes this video and blog post. I hope that this taught you something new and that you're able to set this up inside of your own AWS account as well. Now, again, we are StratusGrid, an AWS consulting partner. So if you'd like to reach out to us, go to stratusgrid.com and reach out to our sales team, myself included as technical pre-sales, as solutions architect. And we look forward to speaking with you. We'll see you in the next video. Take care.